Okay, you're right. What we're going to do from this week onwards is I am going to be uploading 2 lessons a week rather than just the single that I have been. The submission date isn't going to be 2 weeks anymore, it is going to be a week. So, for example, I will upload 2 lessons, one on a Monday and one on a Wednesday. This could be due to change. And I will expect the submission done for the following Monday. Okay, so you'll have the weekend to do it as well. In terms of the format of the lessons, we are changing them slightly. I'm going to be doing a video help lesson or an actual lesson to help you along with the questions on the worksheets that I'll be giving you too. We currently have just started the forces topic. This week you will be doing lesson 1 and 2, okay, and then after half term you'll be doing lesson 3 and 4, then lesson 5, okay, and 6 together, sorry, and then lesson 7 on its own. Okay, so this is 1 week, 2nd week, 3rd week, and 4th week. Okay, and half term is slap bang in the middle. All right, so for today, what I'm going to do is we are going to go over the introduction to forces. Okay, I've already given you the work for this lesson, but I have had a little bit of a response back saying that you were struggling with some of the questions. So I thought I would upload this video now for you. Okay, so introduction to forces. Right, what is a force? Okay, so think about what you've learned in your forces this year. All right, what I would like you to do now is to pause the video and write down as many forces as you can remember. All right, so pause the video now. Okay, so here is an example of a force. Okay, both guys pulling on a rope, all right, producing a force. This is also an example of a force. Okay, in fact, 2 forces. You've got one going against the seagull and you've got one going down. Okay, so the one going down is going to be weight. Okay, and the one at the top, all right, resisting the movement of the bird, is going to be air resistance. All right. And the next one, okay, this is a book resting on top of the table. Okay, so gravity is going to be acting against that book, all right, pulling it down towards the earth. All right, and the force, we call that is again weight. All right, and then the upwards force, okay, is the table making contact with that book. All right, sometimes we call it a contact force, sometimes we call it a normal. All right, so I'll put both down. Contact or normal. Okay. So very quickly, I'm going to go through the forces that you should know, all right, by the end of this lesson. So you've got friction. If you rub your hands together for 10 seconds, you will feel them starting to get a little bit hot. Okay, this is called friction. All right, so friction occurs when we rub 2 objects against each other. Okay, and to prevent this friction, we can use something called lubricant. Okay, and this lubricant, all right, allows there to be less friction. Okay, so I will draw you a little something. If you imagine that this is the surface of a table, okay, if we look really, really close up, all right, if we were then to put some oil over that table, all right, we would then fill up those little grooves. All right. And we would then make the table really, really smooth. Okay, so imagine a little bit like polish. Okay, so we've now made that really, really smooth. There is less friction. Okay, this is useful for things like gears on your bike, okay, but not so useful for your brakes. You want friction, okay, to act when you're braking. Upthrust, okay, an object that floats has its weight, okay, so gravity acting upon its mass, right, balanced by force pushing upwards. This is called upthrust, or you might have heard it called buoyancy, okay. Upthrust keeps things afloat. All right, objects seem to lose weight in liquids because of this upthrust. Okay, so if you imagine, I'll draw you a little boat, maybe, if it works. There you go, a little boat with a little sail. Okay, and you imagine the water. All right, it's floating. Okay, there is, all right, a balance of forces. Okay, the water, all right, pushing against, and weight going down. Okay, for them to be balanced, all right, the forces have to be equal. Air resistance. Now, if you take two sheets of paper, one untouched and one scrunched up into a ball, and you drop them, one's going to hit the ground before the other. All right. Air resistance is a drag that aeroplanes or parachutists feel when moving very quickly through the air. All right. Air resistance increases the faster you move, but if you have a really, really streamlined car, for example, the air resistance is less on it. So if you think about Formula One cars, they are designed to be as aerodynamic or streamlined as possible to reduce that drag so that they can go faster. Electrostatic force, okay? Electrostatic is the force that causes two balloons to repel, okay? Or if you rub a balloon on your hair and then sort of hold your balloon slightly away from your head, the hair is attracted to the balloon, okay? That is an electrostatic force. Now, gravity, okay? Gravity acts upon your mass, so acts upon you as an object, all right, pulling you down towards the center of the earth. All right, so gravity isn't actually a force, okay? Weight is the force caused by gravity acting upon your mass. All right, so we could say here that actually it should be weight. Magnetism is a force. If you hold two magnets together, they will either attract or repel, depending on what poles you have close to each other. So as I've written here, two ends repel if they're the same poles, and they attract if they are opposite. All right, so there are two groups of forces that we talk about in science. We talk about contact forces and non-contact forces. All right, so have a think about what a contact force might be and what a non-contact force might be. All right, and see whether you can write down a small definition for me. Pause the video here. Okay, so definition-wise, all right, a contact force is a force that acts between two objects that are physically touching. Okay, so a contact force has to have contact. All right, a non-contact force are forces that act between objects but are not physically touching each other. Okay, so an example of a contact force would be something like air resistance. Okay, and an example of a non-contact force would be something like magnetism. All right, those magnets, when they act upon each other, are not touching. Okay, you think about two magnets repelling, all right, that magnetic force, all right, those magnets are not touching. Okay, so what I want you to do here is I've given you 7 different forces. I would like you to separate them up into contact and non-contact forces for me. So if you've got paper in front of you, what I'd like you to do is to draw yourself a table. I want contact on one side and non-contact on the other. All right, and then just pop them down. Pause the video if you would like to here. Okay, have we got those? If you haven't, all right, what I would like you to do is just to pause the video here, put them in the right order for me, okay? All right, so to show forces acting upon an object, we use arrows to represent those forces, all right? So for example, this car here, okay, they always start, right, in the center of the object, the center of the mass. Okay, and as it says in that star, the bigger the arrow, the bigger the force. All right, so it's important that when you do this, you use a ruler, all right, so you can show the different sizes in forces, all right, and if they have to be the same size, you get the same length of arrow. Okay, so the forward force, okay, thrust on this car is 1,000 newtons. Okay, newtons underlined here. This is the unit of force. Okay, so that is what we use to measure forces. Okay, or it's the unit of force. We use a Newton meter to measure the force. All right, so forward, okay, we had the forward force of the thrust, okay, but actually there should be another few forces on that car, all right, that we haven't gone through. So a resultant force. If you have more than one force acting upon an object, which you usually will have, all right, we can actually calculate the resultant force. So the result of all those forces acting upon that object. Okay, and we can replace all the forces acting upon that object with the resultant force. Okay, so the result of those forces, as I've said. All right, so for example, this pie on the plate, all right, it has a downward force and an upward force. Okay, gravity down is 10, all right, and the contact or normal force up is 10. It's balanced, all right? That pie isn't going anywhere. So the resultant force, okay, so the resultant force of the 10 newtons here and the 10 newtons here is 0. There is 0, okay, 0 result, it's balanced. So how about this one? Which is the resultant force in which direction? Okay, so I'll leave that there for a sec, just have a think. All right, what's the resultant force and in which direction will it go? Pause the video here if you would like to think about it. Okay, so the forward force, okay, the thrust is 2,000 newtons, and we've got an air resistance, okay, drag of 500 newtons. So there's quite a big difference there. Okay, so we've got 2,000 newtons minus 500 newtons. That gives us 1,500 newtons, okay, in this direction. All right, so in the forward direction, okay. 2,000 newtons is a lot bigger than 500 newtons, so it's going to move forward. All right, there we go, to the right. So have a go at these, okay? Pause the video here, just have a think, you don't have to write them down. All right, just have a think, which direction and what is the resultant force of these pictures. Okay, pause the video now. Okay, so answers. This first one, all right, we've got 6 newtons upwards and we've got 5 newtons down. Okay, so we do 6 minus 5 gives us 1 newton. Okay, and it's going to go upwards. All right. Now the next one, we've got 3 up and we've got 3 down. 3 minus 3 gives us 0. So there's going to be no resultant force. Okay, this next one, all right, we've got 10 one way and we've got 20 the other. All right, so 20 minus 10 gives us 10 newtons in the right direction. This next one, we've got 50 newtons right, 65 newtons left. 65 minus 50 gives us 15 newtons left. Okay, I'll colour in that one too. All right, next one, you've got 40 up and 10 down. So 40 minus 10 gives us 30 newtons. All right, and we're going to be going upwards. Next one, you've got 35 minus 35 gives you 0 newtons. Your next one, you've got 35 left and you've got 20 right, which gives you a total of 15 to the left. Your next one, you've got 8 left, 6 right, so that is 2 newtons to the left. Your next one, we've got 40 up and we've got 38 down, so that gives us 2 newtons and it's going to be going up. Your next one is slightly different, okay? So you've got 4 different forces here, okay? You've got one acting up, one acting down, one to the left and one to the right. Okay, so the first thing we've got to do is I can see here that we've got a 10 newtons there and a 10 newtons there. Okay, so very quickly, 10 minus 10 is going to give us 0. So there's no resultant force up or down. However, if we do 15 minus 5, we get 10 newtons of a resultant force, and it's going to be going left. Okay. Have a look at your answers, check them, all right? And pause the video here just to make sure that you've got them all correct or to adjust. Okay, so how do resultant forces affect the motion of an object? So if you've got a car, okay, that's got a resultant force of 0, all right, the direction and speed of that car, if it is moving, isn't going to be changed, okay? So if that object has a resultant force of 0 and isn't moving, it's not going to start moving. It's going to stay stationary. Okay. If that object is moving at a constant speed, okay, the forward force that's making it move has to be equal to the backward force for it to be a constant speed. The resultant force is 0. Okay. Now, if the resultant force does not equal 0 on an object, it's either going to speed up, slow down, or change direction. Okay. If you suddenly take your foot off the accelerator of a car, that forward force is going to reduce. The resultant force is going to be greater, going backwards, all right, on that backward force. Therefore, you are going to slow down, all right? So there we are. All right, so if the resultant force equals 0, it remains still or a constant speed. If the resultant force does not equal 0, the object will accelerate or decelerate or change direction. That's important. Okay, so here's an exam question just to make sure that you have understood everything that I've gone through today. So, the diagram shows the horizontal forces acting on a car travelling along a straight road. You've got 500 newtons backwards and you've got 2000 newtons forward. Okay, so the thrust is probably 2000 and the drag air resistance is 500 newtons. So calculate the size of the resultant force acting on the car. Show clearly how you work out your answer. If it shows this here, that means it wants you to write down your workings out. Okay, you will get 2 marks for that. Now, describe the motion of the car when the forces shown in the diagram act on it. Okay, so look at the forces in the diagram. Use your answer to 1I to answer II. Okay, pause the video now. Have a think about what you would do. Okay, so to work this out, it's very similar, okay, to what we were doing before. All right, you've got 2000 newtons forward and you've got 500 going backwards. 2000 minus 500 gives you 1500 newtons. That is your resultant force. Okay, that's all you have to do for that one. Now, describe the motion of the car when the forces shown in the diagram act upon it. There is a resultant force. Okay, as we said before in the previous slide, if there is a resultant force, okay, and it is not 0, something is going to change about that object. Okay, albeit its movement forward, its movement backwards, okay, it might accelerate, it might decelerate, it might change direction. Okay, in this case, the resultant force is forwards, therefore it's going to accelerate. So to describe it, you could say the car's motion will get faster as the resultant force is 1500 newtons in the forward direction. Okay, all right. So let's have a look at the mark scheme. Okay, ignore that bit. So you could say that it is 1500. Allow 1 mark. Have a look at this bit here. Allow 1 mark for subtraction. Okay, so even if you didn't get the right answer, if you did subtraction, okay, you would have got 1 mark. All right. Your second one, it gets faster, it accelerates. Okay, they would probably like you to use that word acceleration, accelerates in a forward direction. Okay, that is showing that you understand those resultant forces. Okay, so here's another exam question. All right, so the diagram shows an aircraft and the horizontal forces acting on it as it moves along the runway. The resultant force on the aircraft is 0. What is meant by the term resultant force? Then describe the movement of the aircraft when the resultant force is 0. So these are 1 mark each, so you don't need to have that much detail. Okay, so pause the video here, answer the questions. Okay, so what is meant by the term resultant force? So the resultant force is the overall force acting upon that object. Okay, so when more than one force is acting upon an object, it is the overall force. All right. Describe the movement of the aircraft when the resultant force is 0. So when the resultant force is 0, remember, okay, the object either stays stationary, still, or continues to move at a constant speed, so the same speed. In this case, okay, the aircraft is moving along the runway. So therefore, okay, the aeroplane is going to continue to move at a constant speed. So the aeroplane will continue to move at a constant speed, okay, along the runway. All right, let's have a look. So a single force that has the same effect as all the forces combined. Okay, so there we go, look, the overall force. All right, constant speed in a straight line. Do not accept stationary. Okay, do not accept stationary. It mentioned in the question it was moving. All right, so you needed to read the question carefully. Okay, last one. So this is a little bit small, all right, but I just wanted to pop this on here to make sure that you understand. So the diagram shows a skydiver in freefall. 2 forces, X and Y, act on the skydiver. Complete these sentences by crossing out the 2 lines in each box that are wrong. Okay, so you've got force X is caused by, force Y is caused by, and then you've got to cross out the ones that are wrong. Question B, the size of force X changes as the skydiver falls. Describe the motion of the skydiver when force X is smaller than force Y, force X is equal to force Y. Okay, so let's have a look. X is going against the skydiver, okay, so that's going to be caused by friction. So we cross out those 2. All right, force Y is caused by, let's have a look, so Y is going down, all right, so it's going to be caused by, oh, yeah, gravity. Okay, so when the size of force X changes as the skydiver falls, so X, the air resistance, okay, changes as the skydiver falls. Describe the motion of the skydiver when force X is smaller than force Y. So that means, okay, there is going to be a resultant force greater than 0. Okay, and this one, force X is equal to force Y, will mean that there is a resultant force of 0. Okay, see whether you can answer those two for me. Pause the video here. Okay, so what's going to happen to the skydiver when force X is smaller than force Y? So therefore the resultant force is greater than 0. Well, it's going to accelerate. He will accelerate. Okay. All right, you could add downwards. Okay. Force X is equal to force Y. He will fall at a constant speed. Let's have a look at the answers. Okay, so friction, gravity. All right, we got those two. So you should have said something along the lines of accelerates. Okay, velocity increases, downwards. All right, downwards. That's important for that second mark. And for 2, it's constant speed. Okay, 0 acceleration. All right. And that is the end of today's lesson. So what I would like you to do now is to have a look at the questions that I've uploaded previously to this. Okay, see if they help you to understand what the questions are asking. All right, if you're still stuck, please pop me a message on Show My Homework and I can give you some extra resources. Okay, thank you.